Okay, Hisham, I have a message from you saying to start, so I'm going ahead. Now, can you hear me on the audio? Please respond. Yes, you can hear me on the audio. Okay. Boy, I'm telling you, this this Zoom system is absolutely terrible. Anyway, here we go. Ethical issues from the Kansas City Hyatt hotel collapse. And let me see if I can get my controls to work properly. All right. Okay, what we're talking about here. Well, first of all, let me give you a quick opening remark. The way the webinars proceed here is I press on with the discussion for 50 minutes and then take a 10-minute break so people can check their emails and do things like that. Come back, do another 50 minutes, 10 minutes, 50 minutes. And this, of course, is just a 2 PDH or 2-hour webinar. So we'll only go through that process twice. And this is, of course, an interactive webinar, and questions and comments are welcome and encouraged. And to the best of my ability and the ability to deal with this Zoom system, I will respond as we go along. And I believe also these PowerPoints that you'll be looking at today, we will be looking at today, I believe that you can get a copy of them from the sponsor by going to their website and following the instructions, and you should be able to get a copy of these PowerPoints if you're interested. So what we're talking about here took place in July of 1981. So quite a while ago, that's true. And it was the most disastrous structural engineering failure in US history to that point in time. And it probably still would be there as the most disastrous today. Some people might say, well, what about the Twin Towers situation in New York? But the Twin Towers were not designed to have an airplane fly into them. So that wasn't really a structural engineering failure. So this Hyatt hotel collapse is probably still the most disastrous in US history. Let's see, I'm going to check my chat box. Okay, everything seems okay. And it took place in July of 1981. And what happened was that 2 interior walkways in the atrium lobby collapsed in the Hyatt Regency Hotel that had just been, the construction of which had just been completed a short time before this. And there was a resulting loss of 114 lives and injuries to 200 others. And that's what we'll be talking about today. And also, I will have my comments on the ethical failure that took place, or failures that took place, both before, during, and after the incident. And of course, they are my personal views, and others might see things a little bit differently, but that's what we're talking about today. So anyway, here's a little bit about, by way of introduction, a little bit about me and what I've been doing for the last few decades. for 35 years, I was what I characterize as a straight ahead designer, cranking out drawings and specs for the construction of buildings and a fairly broad spectrum of infrastructure features. For an additional 9 years after that, I was out of the design business. I was in what might be called the public policy business, where I was a principal staff advisor to the California legislature on infrastructure and capital outlay issues. I got registered in a few different things along the way. I'm basically a mechanical engineer. That's my degree in my first registration, but don't hold that against me because even a mechanical engineer can understand what went wrong with this failure, which was, of course, a structural failure. So here's kind of what I'll be talking about, sort of the chapters in the book, if you will. Hang on a second while I once again check my controls. And I am assuming that you can all still hear me. And if you can't, you need to speak up or send me a chat message and we'll try to deal with it. But we'll keep our fingers crossed and hope that Zoom doesn't do a number on us today. So what I'll be talking about, I'm going to be talking about the history of the project, how it came into being. And that is important because that, I think quite clearly, is what led to this structural failure. We'll look at the structural failure, what it was that failed in the structure. And it's pretty simple and understandable. We'll get to that. And then the third thing is the post-mortem. That is the finger pointing that went on after the incident took place. And there were, in my view, significant ethical failures that took place after the incident. Some things we'll try to address was the disaster preventable? Were the after the fact post-mortem conclusions appropriate? Were the actions of professional entities like registration boards, professional societies, etc., were their actions ethical and appropriate? Would the conclusions be different if the failure occurred today? And how do we prevent similar events from happening in the future? And we, as the engineering profession, did learn from this incident. And we'll talk about that a little later, about procedurally ways of doing business were changed, if you will. Okay, here's now is what we're talking about. This took place in Kansas City, Missouri, not Kansas City, Kansas. And here is the structure we are talking about, the Hyatt Regency Hotel in Kansas City. And it had kind of three modules, if you will. There was the high-rise tower portion where the sleeping rooms were located. Then there was kind of a meeting rooms module, or a kind of a mini convention center type module. And then in between them was an atrium lobby. And it was this atrium lobby where the incident took place. This is just a simple little plan view, the tower, the atrium lobby, and then the function block or meeting rooms block. Here is what this atrium lobby looks like today. It's not what it looked like in 1981. another view of the atrium lobby today. Now, the way this building was massed with the sleeping room tower, the atrium in between it and the meeting rooms, it created a circulation awkwardness. This was designed and intended to be a convention type hotel where you'd have lots of uh, attendees at a convention, and then they would in the morning get up and go to their meeting rooms and have their meetings, and so on and so forth. But the way it was, the atrium was a very high ceilinged space, about 4 stories high. And this was a very popular architectural statement in hotel design back in the 70s and 80s for hotels, to have a very dramatic lobby space where people would socialize and buy drinks and so on and so forth. And in many of these installations, the ceiling in the atrium lobby was very high, like it was in this hotel. It was 4 stories high, so a very grand open space. The problem, the circulation problem was, though, that people who were staying in the sleeping rooms to get to where their meeting rooms were would have to take an elevator down to the first floor, walk across the atrium lobby, and take another, perhaps take another elevator up or to the second or third or fourth floor where their meeting rooms were. And then afterwards, to get back to their room, they'd have to take the elevator down in the meeting rooms block, walk across the lobby, take another elevator up in this sleeping rooms tower. So there was this circulation awkwardness. And the architectural solution that was arrived at by the designers of this hotel was to put walkways at the second, third, and fourth floor levels, so that a person staying in the sleeping room tower would just take, if he had a meeting on the 4th floor in the convention module, would just take an elevator down to the 4th floor, walk across one of these walkways to where his meeting was. So the circulation was greatly simplified by doing that. And these walkways are indicated schematically in this little sketch. They were suspended from the ceiling of the 4th floor and on rods. And this, as you will see, is where the failure took place, the structural failure took place. So there were 3 of these walkways at the second, third, and fourth floor. The second and fourth floor walkways were one on top of each other. The third floor walkway was kind of offset, was offset. And here's a cross-sectional view showing these walkways. And as you can see, they structurally, they are suspended from the ceiling structure at the 4th floor. And so the load from the walkways is transferred to the ceiling structure at the 4th floor. And from there, it finds its way down to the down to the foundation. This is just a plan view showing the framing of a typical walkway. You'll see more photos. And here is what happened right after the incident. In 1981, the second and fourth floor walkways, the fourth floor walkway started the collapse. It dropped down onto the second floor walkway, and the second floor walkway collapsed. The third floor walkway was offset, and it was not involved. So now let's look at the history of the project, because as I see things, this is where the ethical failures begin. So in 1976, the commercial and governmental entities in Kansas City, they wanted to get a convention hotel constructed downtown. And hotels, of course, always have been and continue to be kind of difficult economic animals to make them work out. They're not overpoweringly profitable, but they're viable if done correctly. So the civic and commercial interests in Kansas City wanted to get a convention hotel constructed downtown, and so they went to the Hallmark card company, the Hall family, that had always been very big civic boosters and activists in Kansas City. And at the time, a very profitable company. And so the Hall family was approached about being the developer, the owner, if you will, of the hotel. And this, of course, is pretty typical these days. You have these hotel companies that their names are very familiar: Sheraton, Hilton, Hyatt, et cetera, but these in this day and age, and in that day and age, they were really just operating companies. They didn't own any hotels to a large degree. A real estate developer of some sort would build a hotel, and Hilton or Sheraton or Hyatt would operate the hotel. And so the Hall family set up something called the Crown Center Corporation. And this was the official owner of the facility, with the Hall family and the Hallmark card company backing it financially. And so that arrangement was put together, and the owner then, Crown, entered into an agreement with the Hyatt Hotel organization to operate the hotel. And it's not crystal clear how early Hyatt got involved in the planning and design of the hotel, but it's probably highly likely that the Hyatt Corporation was very closely involved in the planning and the design, and then the construction of the hotel, simply because the operating companies know what features that they want to have in the hotels that they're going to be managing. So Crown Corporation is the owner. Hyatt Corporation is going to be the operator of the hotel. And then Crown, the owner, took the next step and hired a traditionally trained, you might say, firm of architects, an organization called PBNDML, Architects Planners Incorporated. And PBN, et cetera, was to be the prime design contractor, according to the record, responsible for all aspects of the building design. PBDML's fee was $1,650,000, approximately 6.1 million in 2009 dollars. The last time I calculated these, brought these dollar figures up to date. Today, that would probably be in the ballpark of 10 million, something like that. And I mention these fee amounts because one of the questions that is raised is, was the money being spent in the right place? Was it available to the appropriate participants in the design and construction process, such that they had enough money to do the work that they needed to do safely? And this raises the issue of economic pressures in the design and construction business. I think all of us who are now or have been in the design business and also the construction business know that there are very, very significant economic pressures that the designers and builders of buildings are subjected to. So the PBNDML was hired by Crown to be the prime design contractor. And of course, a common arrangement back at that time and continuing today is that in fact, the prime design contractor, often a traditionally trained architect, has to subcontract out a great deal of the design work because it doesn't, a traditionally trained architect or architectural firm doesn't have the capabilities to design a building. They have certain aspects of the design process that they are qualified for, but only a relatively smaller portion. So the master designer PBNDML hired a subcontractor, sub-design contractor to do the structural engineering for the project. And the firm that they hired was Gillum Colaco. Gillum Colaco's fee was 247,000, approximately 921,000 in 2009 dollars. Was this devoting sufficient funding to the structural engineering of the building? That's a question that can be asked. And also, it's not any secret that when a prime design contractor, perhaps a traditionally trained architect, subcontracts out the structural engineering, the civil engineering, the mechanical engineering, the electrical engineering, etc., that it's the contracting process is very, very frequently, if not always, done on the basis of lowest price. The structural engineer that offers to do the structural engineering for the lowest fee is probably the one that's going to get the job. And so economic pressures, and I'm emphasizing this because this is a very important thread that runs through this story. So the master designer, the traditionally trained architect, PBNDML subcontracts the structural engineering design function to an entity called Gillum Colaco. And Gillum Colaco, for reasons that are not crystal clear from the record, then subcontracted the structural engineering work to an affiliated firm, Jack D. Gillum and Associates, for an unknown fee. And Gillum, the nominal structural engineer on the project, prepared approximately 60 drawings for the structural design of the project. And keep that figure of 60 drawings in mind, because that is a good piece of data to be aware of as we move forward with this. And of course, the master designer, architect subcontracted the civil engineering work to a civil engineering firm, mechanical engineering to a mechanical engineering firm, et cetera, et cetera, et cetera. So there were a whole slew of design firms involved. Not uncommon at all, but this is important, I believe, and hopefully this will become clearer as we move forward. So Jack D. Gillum is goes to work on the drawing boards and produces 60 drawings for the structural design. And the design of the project began in 1967. Crown, the owner, also brought another actor onto the stage. And the picture that I am trying to paint here is to get across that this stage is getting a little crowded with actors. And Crown brought on board as a construction manager a firm named Concordia Project Management Limited. Concordia's role is not crystal clear from the record, but it is characterized by the record as being a construction manager. So that's an important point. The design was substantively completed in 1978 and was competitively bid for the construction work. Again, economic pressures are looking over the transom here. And an entity called Eldridge Construction Company was the lowest bidder and entered into the contract for construction of the project. And as is, of course, common in the construction end of things, the prime general contractor is not very likely to be out there on the job hammering nails, twisting pipes, and connecting wires, things like that. The actual construction work is typically done by trade contractors, electrical subcontractor, plumbing subcontractor, HVAC subcontractor, steel erection subcontractor, et cetera, et cetera, et cetera. So Eldridge, the general contractor, construction contractor, subcontracted the structural steel fabrication and erection work to an entity called Havens Steel Company. And Havens's contract was for $390,000, approximately $1.5 million, in 2009, maybe a couple million or so in today's dollars. So more people getting involved here. Eldridge Construction, the master builder, Haven Steel, and as is almost certainly the case in the construction end of things, the subcontractor that gets the subcontract is almost always the lowest bidder. So economic pressures again, and Havens was undoubtedly subjected to those and almost certainly had to bid competitively to get the subcontract. Havens, as part of its way of doing business, it advertised and held itself out to its customers as providing engineering services as well as fabrication and erection services. So here is Havens, another party with some apparent engineering capability. And so more actors purporting to have engineering capabilities. Havens, the steel erection and fabrication subcontractor, subcontracted steel detailing work to an entity called WRW, which was a company which had an experienced registered professional engineer as a principal. So another actor comes on stage with engineering or purported engineering capabilities, and WRW prepared about 40 structural drawings for design of the project. Now, this was then and continues to this day to be a common business practice. In the early days of structural engineering, the structural engineer would do a complete detailed design for a building structure, size the beams and the columns and the connections and the details and so on and so forth. But quite probably because of economic pressures, the structural engineers in those early days were not averse to offloading part of the work because of economic pressures that they were subjected to in the process. And the steel fabrication and erection contractors said, well, you just size the beams and the columns and so on and so forth, and we'll do the detailing of the connections. So we'll do those in that detailed design such that it probably makes their life easiest. And so that's this traditional method of getting structures designed and built back at that time and continuing today results in a division of work in the structural design. You'll recall that Gillum prepared about 60 drawings for the structural design for the work, but this entity WRW prepared about 40 drawings for the design. So almost a 50-50 division of the work of the design. More actors keep wandering on stage here. Crown hired an inspection firm called H&R Inspection General Testing to assure the quality of the construction work and its conformance with the working drawings and specifications. This firm, known as General Testing, had a registered professional engineer in its employ. So another actor comes on stage with some degree of technical competence. What was general testing's specific duties, not real clear from the record, but it's another actor on stage. Now, some data points, again, kind of reflective of the issue of economic pressures in the business that we're in. On 3 occasions, Gillum, the nominal structural engineer, requested funding to have a full-time inspector or project quality control representative on the job site. A very common undertaking or way of doing things in a safe, reasonable manner. To have, for the structural designer, the structural engineer, to have an inspector on the job site, and often full-time on a large project. But Gillum's requests for funding for a full-time inspector on the project were denied. Who denied them? Was it Crown? Was it the construction management firm? Did the Hyatt people have any involvement in denying this funding request? Hard to say, but in any event, Gillum said, we need to have a full-time inspector out there on that project, and I need funding for that. Answer comes back, no, you can't have the funding for that. Another interesting little data point in this, what's turning into a lot of cats running around, is that the specifications for the project, according to the record, were prepared by the master designer architect PBNDML, not by Gillum. The record indicates that the structural aspects of those specifications were, quote, reviewed and commented upon by Gillum. But this is I think is clearly a very unusual and potentially hazardous way of doing business, to have the structural specifications for a project prepared by a traditionally trained architect, because the architect has no competence in structural design. So another data point, things being done. Was this done again because of economic pressures that Gillum said, I need more money if you're going to have me do the specifications as well as the drawings, and the somebody said, no, we're not going to give you money for that. Was that PBNDML that didn't want to provide funding for Gillum to prepare the specifications? I don't know. The record has a few holes in it. Another data point in this incident took place during construction. On October 14th, 1979, the building is under construction, and over a weekend, on a Sunday, a portion of the atrium ceiling structure collapsed. Fortunately, because the collapse occurred on a weekend, there were no workers present, and there were no there were no injuries or fatalities. The owner retained an independent structural engineering firm, an entity called Seiden Page, to investigate the cause of the roof collapse. Seiden Page identified the cause, and design changes were made by Gillum. but Seidenpage was not retained to investigate the adequacy of any other structural features of the building design, such as the atrium walkways. Now, it seems like an incident like this, the collapse of the roof structure while the building is under construction, should have set off alarm bells that something wasn't going real well on this project and that the structural design needed a comprehensive technical review. But the owner or somebody who was in the chain of control of the money said, no, we don't want to pay Seidenpage to do this extra work. Just have them tell us what we need to do to fix this collapsed roof portion. Not a prudent way to respond, I would suggest. So the construction was completed and the hotel opened for business in July of 1980. July of 1981, only a year after the construction was completed, there was a social function going on in the hotel. And it apparently was sponsored by a local radio station. It was purported to be a dance contest, and there were about 1,500 people in this atrium lobby. And they were not just down on the ground floor of the atrium lobby, they were up on these walkways that were crossing the atrium lobby at the second, third, and fourth floor levels. And there were people on them, and they were socializing and they were drinking. Perhaps they were doing a little dancing around. But a large crowd on the ground floor level and on the walkways. With this situation, the structural failure occurred at the first at the fourth floor walkway, which failed, crashed down onto the walkway at the second floor. The two of them crashed down to the ground floor level. Any fatalities and injuries. The walkway at the third floor level was offset and was not involved in the incident. So this is what just a side bit of information that's not relevant to anything is apparently there was also a convention of doctors, radiologists taking place in the hotel at the time of this party, and a number of the doctors were able to provide some assistance to the injured, but you know, it was what it was. Now, here is what the scene looked like in the lobby after the collapse took place. And you see the walkway structures, and you see a couple of people in this photo to give you an idea scale. So these were big structural elements in the building. Different views here. Here you see the in the upper left third floor walkway is not involved and is still in place. Here you see the broken suspender rods for the second and fourth floor walkways. Now, the second and fourth floor walkways were attached to the same set of suspension rods. Here's the third floor walkway suspended from its suspender rods. More pictures. Okay, now, well, let's press on for another 5 minutes here, and then we'll take our first break. So the failure takes place. What went wrong? In the initial stages, one theory that was thrown out there was of harmonic resonance, that the people on the walkways were dancing around, walking around, doing whatever they were doing, and that they were doing so as a forcing frequency that was at or close to the resonant frequency of the structures involved, the walkways, particularly the walkway at the fourth floor level, and that this resonance, as resonance does, if it's not mitigated in some way, it just keeps increasing and increasing, and the amplitude of the oscillation increases until ultimately the structure fails. And so that was one of the first theories that was put out there, and it was discarded fairly expeditiously, and it's it was discarded because the actual cause, which you'll see shortly, was discovered, and the actual cause of the failure was a change that was made by the steel detailer, WRW, at the instigation of Havens, the steel erection and fabrication subcontractor. A change that WRW made to Gillum's design. And this change was made in the preparation of the shop drawings prepared, or the detailed drawings prepared by WRW at the instigation and direction of Havens. And that was the cause of the failure. Now, I think we'll stop and take our first 10-minute break now and come back, and then we will look at the actual failure, and it's pretty clear why it occurred. And then we will look at the post-mortem, or the finger pointing that took place as a result of this incident. Everybody, as is typical, stands in a circle and points at the guy on his left and says, "He did it, I didn't have anything to do with it." And then we will look at the behavior, if you will, of certain professional engineering entities, engineering societies, registration boards, what took place in the finger pointing phase. And I think that what was done in the finger pointing phase was one area was particularly highly unethical, but we'll talk about that later. So let's take our first 10-minute break right now and come back on the hour, and we'll take a look at the failure, what actually failed, and then we'll look at the what went on in, as I characterize it, in the finger pointing phase. So I'll see you all in 10 minutes on the hour. Okay, this is Paul Geyer and I'm back. So, Havens, the steel fabrication and erection subcontractor, directed WRW, a steel detailing firm with a professional engineer as a principal, to make a change in Gillum's design. And why did Havens do this? Well, Havens did it in a fundamental way because of economic pressures. Havens undoubtedly had got the subcontract because it was the lowest bidder to Eldridge. And so a part of the economic pressures that everyone in the design and construction business is subjected to. And the items that Havens was concerned about, two constructability issues. And you'll see this illustrated here shortly, but these suspension rods that were carrying the load from the second and fourth floor walkways, they were 40 feet long. Again, remember this big high atrium ceiling. And these were in Gillum's design, continuous suspension rods about 30 feet in length. And Havens took a look at those and said, boy, those are going to be very difficult to handle and install. And we need to come up with a less awkward design. Now, there is no question, I think, that having rods this long in Gillum's design was sloppy, or, yeah, kind of sloppy work on the part of Gillum. Gillum just didn't take the constructability issue into account. And that was a bit of constructability that Gillum did not do a good job on. But these long suspension rods, that was not the cause of the failure. The second constructability issue in Gillum's design, in addition to the length of these suspension rods, is that they would have to be threaded for a distance of about 30 feet in order to install a nut on the rod that supported the fourth floor walkway. You'll see a sketch of this shortly. Another constructability, poor constructability work on the part of Gillum. So the very long length of these suspension rods, and the fact that they would have to be threaded for about 30 feet of their 40-foot length in order to install this critical nut. So Havens directed Gillum to change, Havens directed WRW to make a change to Gillum's design. And here is the change that WRW Havens made. This is Gillum's original design for the connection of the suspension rods at the fourth floor walkway. The framing of the walkway's deck was, as you kind of see here, there were box beams that were fabricated out of two I-beam channels, or not I-beam channels, C channels, and welded together to form a box beam. And then a hole was drilled in the box beam. And in Gillum's design, then the suspension rod was passed through the drilled hole in the box beam, and a nut was threaded up from the bottom. This is where the 30 feet of threading on the suspension rods comes into play. It's to position the to get the this nut into position, and then the box beam at the fourth floor walkway rests on the nut. And this was Gillum's design. Not good from a constructability standpoint, but if Gillum's, as was subsequently proven, if Gillum's design had been constructed, this incident would not have taken place. It would not, this connection would not have failed. So, but because Havens saw the constructability issues and said, my gosh, that's going to be a mess, difficult and expensive to do, he directed Havens directed WRW to change the connection detail to what you see here. The suspension rod drops down from the fourth floor ceiling structure to the fourth floor walkway. And that suspension rod passes through a drilled hole in the box beam, and a nut is positioned at the end of that rod. And then a second rod is used to drop down to the second floor level and pick up the load from the second floor walkway. So the load from the second floor walkway is transferred to the second suspension rod, which transfers the load to the box beam, and the load is transferred laterally to the second or first suspension rod. And the box beam was never identified, or was never intended to or designed to carry that load, transferring it from the lower suspension rod to the higher suspension rod. So here was Gillum's design. In Gillum's design, the load on the nut at the fourth floor walkway was whatever it was, P. But with Havens WRW's design, the load on the nut at the fourth floor walkway is now 2P. That's because the second floor load was not being transferred directly to the suspension rod that ran continuously up to the fourth floor ceiling structure, but rather was transferred by the box beam at the fourth floor level. So Havens WRW's change to Gillum's design doubled the load on the nut at the fourth floor. And this is where the failure occurred, at that nut at the fourth floor level. There was another consideration that came into play here, and that is that in Gillum's original design, the suspension rods were sized so that they were strong enough to support only 60% of the imposed load based on code allowable stresses. And that's important, code allowable, because the allowable stresses in building codes are typically a third to a half of yield. So even with this error, and it was an error on Gillum's part, undersizing based on the code allowed stresses of the suspension rods, even given this error by Gillum, the failure would not have occurred for the simple reason that the code allowed stresses are a third to a half of yield. So this is the resulting failure that took place at the fourth floor. The box beam you see has failed, and the nut has pulled out. More pictures. So now the finger pointing. Havens made this change on the shop drawings and submitted them to Gillum for review and nominally approval. But of course, as you'll see later on here, the practice universally is that when shop drawings make changes to the original designer's design, the shop drawings are reviewed, but the subcontractor that made the change to the design is responsible for the safety and adequacy of the redesign. And so the shop drawings were submitted, 40 of them, to Gillum for review. And this fatal change was on one of these shop drawings. Gillum reviewed the drawings, and they were stamped with a typical shop drawing review stamp, quote, reviewed only for conformance with the design concept and for compliance with the information given in the contract documents, end quote. So that's how Gillum stamped these shop drawings. And Gillum did not take note of this design change that Havens had made. Another piece of sloppy work, one might say, on Gillum's part. But the reality is that in the design and construction business, people make mistakes all the time. And you have to have an organizational in my view, an organizational structure and procedures in place and enforced that, in my view, force as many sets of eyes as possible to look on the relevant documents in the process, the design drawings, the shop drawings, the submittals, et cetera, because with as many sets of eyes as possible looking at these shop drawings, there is a hope, and often a justified hope, that somebody will spot these changes and will sound an alarm bell. They'll say, hey, this doesn't look right here. And then the relevant designers will take another look at it and say, oh, yes, you're right. That was incorrect. So we'll change that. But that was not the case here. The shop drawings were sent directly from Havens to Gillum, and they did not go through the all pass under the eyes of all of the appropriate participants in the design and construction process. There's a sketch of this later on to kind of illustrate this point of getting as many sets of eyes as possible to look at these relevant documents. Because not every participant in the design and construction process has the same level of technical competence, but they all have some level of technical competence. Even a journeyman carpenter looking at shop drawings might spot the fact that a 10 penny nail was too small to nail these two boards together, things like that. So stamp them as noted here. And so Havens proceeded to fabricate and erect them in accordance with the fabrication drawings that Havens and WRW had prepared. As is not uncommon in a situation like this, several of the participants in the design and the construction process were looking for someone to pin the tail on, to pin the blame on anyone other than themselves. And of course, the easy target, if you will, was Gillum. And so there were several of the participants that said that they told Gillum of concerns that they had about the safety of the proposed change. Included in this group were the construction detailer, WRW, the steel fabricator, Havens, and the master designer architect, PBNDML, and a technician. Now, this is patently unsustainable to say that Havens WRW made changes to Gillum's design on the shop drawings and then contacted Gillum and told him, oh, by the way, we just made a change to your design, but we don't think that the change that we made is safe. I mean, that's just ludicrous. And then, of course, the master designer, architect, PBL. So these participants undertaking what you would expect them to do, people being people, to pin the blame on Gillum. Now, this incident was of major notice throughout the country, in newspapers throughout the U.S. And it was very high profile, and it was important that a credible, very credible technical review of the design and process that went on be undertaken. And the entity that ended up with that responsibility was at that time, the National Bureau of Standards, which today is called the National Institute of Standards and Technology, which is a very highly competent research and engineering standards body, a federal agency. I, number of years ago, actually had some direct involvement with the NIST, National Institute of Standards and Technology, and their campus is very comprehensive, and their staff is of the highest order. So the National Bureau of Standards had the responsibility to review this and the incident to determine the cause. And this is the essence of what the National Bureau of Standards determined. It determined that the design change, which led to the failure at the box beam nut suspension rod connection, that was the cause of the failure, and it failed, and it was contributed to by the failure to design the suspension rods to code approved stresses. Yes, that is correct, but from a practical standpoint, the code approved stresses are substantively lower than stress. So the failure to design to code approved stresses, failure by Gillum to design to code approved stresses, did not cause the failure. And the NBS said that the incident was also contributed by a failure to provide redundant suspension rods. Well, yes, that's certainly a reasonable statement. I mean, but redundancy is something that you do in design when you don't know exactly what you're doing, and you just say, well, let's just throw in a few extra suspension rods just to be safe. But the clear statement by the National Bureau of Standards was the cause of the failure was the design change made by Havens WRW, which led, and that change led to the failure at the box beam nut suspension rod connection. It doubled the load on that nut, and the nut is what failed. The National Bureau of Standards specifically concluded that, quote, the original hanger rod arrangement, continuous rod, the box beam hanger rod connections, as shown on the contract drawings, would have had the capacity to resist the loads estimated to have been acting at the time of the collapse, period, end quotes. And here are those words in the actual executive summary of the National Bureau of Standards report. This material here is simply recounting historically how the way of doing business in structural design developed in the US, where there was developed a division of the design responsibility between the quote structural engineer and the steel detailer. So you're welcome to review this material at your leisure. Now we get into the National Bureau of Standards has completed its report, and it's I would like to be able to show you quickly the National Bureau of Standards report, because it's clear just from thumbing through the pages in it that a very high level of technical competence went into the preparation of it. But I don't have enough of a handle on these Zoom controls to show you that. But at this point in time, then, the National Bureau of Standards has completed its report, and it says very, very clearly, just what you just saw, that the cause of the failure was the change that Havens WRW made to Gillham's design, period. There were these other supplementary issues about not designing to the code stresses, but and the not using redundant rods, but that is specious in my view. But now the Missouri Registration Board springs into action. And at the time that this incident occurred, I was quite close to principal actors on the California Registration Board. And the behavior of the California Registration Board, its response to this incident, was typical of registration boards, I think, throughout the US, and in particular, the Missouri Registration Board. The registration boards said, well, we must find someone to punish for this incident because otherwise the public will lose confidence in the job that we are allegedly doing in regulating the engine in California, in my case, or in Missouri. And it was a rather self-righteous covering of one's rear end that took place. And this took place with the Missouri Registration Board. And so it undertook what it called an investigation. But it was not by any stretch of the imagination a competent technical, was not a technical engineering investigation comparable to that undertaken by the National Bureau of Standards. All that the Missouri Registration Board did was hire a bunch of lawyers, sit around and ask questions of everyone under the sun who had anything whatever to do with the design and construction of this project, and to candidly, and I'm probably not a real fan of the legal system here in the US, but to do nothing but run up big bills. And so that's what the Missouri Registration Board did, is it just hired a bunch of lawyers to ask questions of everybody having the slightest thing to do with this project. And of course, what are these people who are being questioned going to say? They're human nature. They're going to say, I didn't do anything wrong. Somebody else did something wrong. And the easy target for all of these people was Gillum. And so the Missouri Registration Board sanctimoniously, in my view, said that, well, Gillum and another professional engineer employed by him are guilty of gross negligence, misconduct, and unprofessional conduct in the practice of engineering. And the Missouri Registration Board canceled their Missouri professional engineering registrations and essentially ruined their careers. And that was, in my view, highly unethical on the part of the Missouri Registration Board. It did not look at all at the engineer who was a principal in WRW, the steel detailer that actually made the change. It did not look at Havens, which held itself out to the public as providing engineering services. It did not look at the involvement or lack of involvement of the master designer architect, PBNDML or whatever it was. All of that was completely ignored by the Missouri Registration Board. And so I believe that a major ethical failure was that by the members of the Missouri Registration Board. As far as there obviously there was a great property damage, and then of course the personal injury and the deaths of the victims. So there were tremendous damage claims. By and large, as these things usually play out, the entity that ends up paying for these claims is the insurance company, and Crown, being a sophisticated business entity, an offshoot of the Hallmark card company, was well insured, and so the actual damages were paid by the Crown's insurers. Now this is, I wish that I could flip through these pages here and just show you the how detailed and technically competent the investigation was that was undertaken by the National Bureau of Standards. It was 377 pages, highly detailed, and highest technical competence. Here is what the Missouri Board of Registration did was just, as I say, hire a bunch of lawyers to sit around and ask questions, and then come up with a 457-page transcript of the administrative hearing conducted by the Missouri Engineering Registration Board. And all it did was just document everybody who had anything at all to do with the project sitting around and blaming someone else. And the easy target was Gillum. Here, for your information, is an email that I got a while back from an engineer who had some close association with the incident. And he raises some additional valid points, I think. And one of the points that he raises is that there was the welding was inadequate, that was undertaken by Havens. So again, Havens's welding, as described here, was inadequate. And then, of course, there was the fundamental change that doubled the load on the net that the fourth floor walkway load was resting on. And that was the change that Havens directed WRW to make in the shop drawings. You can review this at your leisure. So, was the disaster preventable? Well, clearly, yes. If Havens WRW had properly designed the changed detail. Now, there again, there is no question that, in my view, that Gillum did kind of a sloppy bit of design work in the from a constructability standpoint. The fact that these suspension rods were 40 feet long, roughly, and that they had to be threaded for 30 feet. Clearly, Gillum appropriately thought and come up with a more reasonably constructible detail. And it would be preventable if the change that Havens WRW made in the shop drawings had been caught by Gillum when the shop drawings were sent over for approval. And additional actions that could have prevented the incident. Yes, if Gillum had provided redundant suspension rods. Yes, Gillum did not size the suspension rods to the code-approved stress levels, but even if he had, the code-approved stress levels are, substantively less than the yield stresses of steel. So the key thing is the change that Havens WRW made to Gillum's design. So there are all of these people on stage for this project, and we ran through them when I was talking about the history, the construction manager, the inspection firm, et cetera, et cetera, et cetera. And so the post-mortem that was finger pointing that was engaged in by the Missouri Registration Board, you have to ask, what's the responsibility of Havens? After all, it was Havens and who directed WRW to make this a change. Havens held itself out to its customers, the record is clear on this, as providing engineering services in addition to fabrication and erection services. So Havens have some responsibility, if not all of the responsibility. What is the responsibility of WRW, the steel detailing firm, which had a professional engineer on its staff, and I think is one of the principals of the firm? What is the responsibility of the master designer, the architect? Our good friends, the architects, like to hold themselves out to the public as being master designers, but in this incident and many others that I've seen over the years, they dive under the table when anything goes wrong. So why wasn't this master architect responsible in some way for the failure, for the incident? What is the responsibility of Eldridge, the general contractor? Because Eldridge also held itself out as being responsible for all of the construction, including that of its subcontractors, in this case, Havens and WRW. So what was the responsibility of Eldridge in this? And then the other actors, the construction management firm, I forget the name, and then the inspection firm, general testing, that the owner retained. And then does the owner have some responsibility for the fact that the Seiden Page firm was not retained to undertake a comprehensive review of the structural design of the building, even after there had been this roof collapse during construction? Clearly, there should have been an alarm bell that went off when that happened. What about the responsibility of the owner or whoever refused to provide funding for Gillum to have a full-time inspector on the project? Who denied that funding? Did the master designer, the architect, refuse to provide funding for Gillum's full-time? Did the management firm refuse to provide funding, et cetera, et cetera, et cetera. Additional points as far as the behavior of the profession to this incident is concerned. ASCE, in response to this incident, pronounced in a grand manner that there are that the structural engineer, quote, end quote, is responsible for all aspects of the structural design practicable. And this was a pronouncement by ASCE, but if you're going, it's fundamental that if you're going to hold someone responsible for achieving an objective, that party has to have the appropriate authority to do what it needs to do to meet its obligation. And this is not the case here, and in typical design projects. The quote structural engineer, end quote, does not in fact control critically the budget for the project, and the that budget control is essential for going to hold a party like a structural engineer responsible for the safety and utility of a design. And the ASCE's pronouncement, I think, clearly completely ignores the significance of economic pressures that exist in the design and construction business, and specifically on the quote engineer, end quote. So it's NSPE came out with a similar pronouncement. So the engineering societies were rather sanctimonious in their response, as were the registration boards, and particularly the Missouri Registration Board, which did not undertake any technical evaluation. And the Missouri Registration Board had at its disposal the technical evaluation by the National Bureau of Standards. All they had to do was read it, and was quite clear in the National Bureau of Standards report that the cause of the failure was the change that Havens, WRW, made to Gillham's design. Nevertheless, the Missouri Registration Board undertook and did to pin all of the responsibility on Gillham, the structural engineer, and ruined his career. So some of the realities, I think, as far as preventing incidents like this in the future, we need to recognize, as we probably do, that the design and construction process is highly complex. It's not only technically complex, it's organizationally complex, because you have so many parties running around with different economic motivations that it's highly complex. And to avoid incidents like this in the future, we also need to recognize, I believe, that people always make mistakes, even professional engineers make mistakes. It's human nature. And what you have to have is an organizational structure and procedures in place that are observed and enforced to force as many sets of eyes as possible to look at the relevant documentation on a project, and the hope being that somebody will spot these kinds of errors and catch them before they end up in an incident like this. Another point as far as avoiding similar events in the future, we need to understand and be realistic. We meaning professional societies and registration boards need to understand the very powerful economic forces that are in play in the process that we're involved in. So this is what I distill things down to as being needed: a clearly defined organizational structure, clearly defined and enforced process and procedures, and independent constructability reviews is something that I put a lot of stock in on major projects. In other words, where you bring in an entirely new set of eyes with appropriate design and construction capabilities to review the working drawings, specifications, and any other documentation on a project. Because again, it's getting those fresh eyes looking at the project. So in the case of this project, the relevant documentation went from the steel detailer directly to the structural engineer, Gillum. It did not get passed up to the field, the general contractor, to the construction manager, and on down through the master designer, architect, to Gillum. So those other sets of eyes did not get to look at these documents. And so I think that's, yes, this takes time, but we're dealing with very complex, expensive, potentially dangerous projects, and you need to take that extra time. So that pretty much gets us to the end of the discussion here. And so I hope this was about what you thought you were getting into when you signed up for this, and that it gives you some idea of some things to think about. There are some additional comments here in the chat box. So I'm going to just leave it to you to review your chat box. They're good comments, and I appreciate those. So anyway, that's the end of my story today. So thank you very much for letting me chat with you today. I hope it gives you something to think about. And with that, I'm going to close things out. So have a nice rest of the day. Thanks a lot. Bye.